Hey everyone, we're back with day 2 of Piecewise-Defined Functions, lesson 4.1. We are on page 59, and we are going to start out by looking at number 6 here, which actually asks us to look back at item 5 from what we did in the last video. So if you look back at page 58, number 5, it says, Esteban says that g of -1 equals 2. Is Esteban correct? Explain. Okay, so he said that g of -1. So you want to look at your g of x and look at -1 and see at -1. Let me use purple here. So we're looking at -1 here. Does g of -1 equal 2? And the correct answer would be yes. And the reason is because we have that closed circle. Okay, so we can pretty much do that with any number. Okay, so if it's asking you to kind of plug in a number for a function, so let's say we did g of, I don't know, let's say 3. We could figure out what g of 3 is by going to 3 on your x-axis and going up and figuring out where it hits your graph. So we would say g of 3 equals 6. Okay. Now you could also realize that 3 is greater than -1. So you could plug it in here. And so we know 3 plus 3 is also 6. So there's two ways you can solve for functions like that. It can either be by looking at your graph, which is what I did here, or it can be by plugging into the correct function rule based on the domain restriction. So if you look at your domain restriction and you realize, okay, well, x is greater than or equal to 3, so we're going to plug it into this function, then you're good to go. Okay, so if we look back at that one, g of -1, where, who was it? Esteban asked what that equals. Well, -1 is equal to -1. So again, we would plug it in here. And -1 plus 3 is 2. So yes, Esteban is correct. Okay. So that's what number 6 is asking about. Explain how to graph piecewise defined functions. We're going to do some more with that today. And then 8 says, if a piecewise defined function has a break, how do you know whether to use an open circle or a closed circle? And we talked about that last time, but open circle would be a less than or greater than. Closed circle would be less than or equal to or greater than or equal to. Okay, all right. Up next, we are going to talk about domain and range. So if we look at our math terms over here, it says the domain of a function is the set of input values for which the function is defined. Okay, so domain is your x, so that's how far left or right your graph will go. Okay, then it says the range of a function is the set of all possible output values for the function. So the range is your y, and that's how far up or down your graph will go. Okay, so that's important. Maybe jot yourself that little note. It says here the domain of a piecewise defined function consists of the union of all domains of the individual pieces of the function. Likewise, the range of a piecewise defined function consists of the union of all ranges of the individual pieces of the function. So basically, it's the same rules apply for domain and range. We just have to look at the different pieces of the functions now. Okay. It says you can represent the domain and range of a function by using inequalities. You can also use the interval notation and set notation to represent domain and range. Okay, so let's go ahead and get started. And number 9 is asking us to refer back to item 5, the graph we did last time. So first, let's talk about the domain. And the domain is your x values. So how far left and right can this graph go? Well, because we have these arrows pointing in each direction, I know that the graph can go on forever to the left and it can go on forever to the right. So your domain should be all real numbers or from negative infinity to positive infinity. So let's go ahead and write this in the 3 different notations that we'll be talking about, okay? So we have inequality, which will look like this. Negative infinity is less than x, which is less than positive infinity, okay? So that means that x can go to negative infinity and positive infinity. Now, we do not put the equal sign underneath there because you cannot equal, you cannot equal positive or negative infinity. That just doesn't make sense, okay? So let's go ahead and erase that real quick, okay? So that's how you write your domain in inequality form. Then interval form is going to be written negative infinity, comma, positive infinity. And we are going to use parentheses. Okay, so this is another thing that differs between less than signs and greater than signs. So that's when you use parentheses, and I would jot down this note for yourself. Parentheses. But if it were a less than or equal to or greater than or equal to, that's when you would use brackets. Okay, so it's the same idea as using a closed circle versus an open circle. It's the same idea as a solid versus a dashed line. We need to be able to tell the difference between a less than or greater than and a less than or equal to or greater than or equal to. Okay. All right, so jot yourself that little note. So that's interval notation, and then the last one is set notation. And that one, this is everyone's least favorite, okay? But we would write that as x, includes, okay, so x is an element of all real numbers. Okay, so basically what this means, the little e means is an element of, and this strange r is all real numbers. Okay, so that's your domain in all 3 forms or notations. Now let's talk about range. Okay, so if we go back to look at number 5, remember range is your y values or how far up and down your graph can go. So our arrows are both pointing up. So can our graph go down? Can it go into the negatives? And the answer is no. Okay, so the lowest point on our graph is right there at 0, right? But we can't even include 0 because that's an open circle, okay? So we don't want to set it equal to 0 because your y values cannot equal 0, but we can say that your range is y, remember range is y, is greater than 0. Now, if that were a closed circle, we would have said greater than or equal to, but again, because it was open, we're just going to say that for the inequality notation, your range is y is greater than 0. Okay? If we're going to write that as an interval, we are going to say from 0 to infinity, because we know it's going up, and both of those get parentheses. Infinity and negative infinity always, always, always get parentheses because we can't include it. And 0 gets a parenthesis here because we don't have an equal sign underneath. Okay, that was our rule over here. And the last one, set notation, we would say that y such that y is an element of all real numbers. And then all you have to do here is put a comma and put whatever you put as your inequality. So y greater than 0. And that is your set notation. Remember, like I said, that is the one we will use least often, but you do need to know what that is, okay? All right, lovely. So now that we know domain and range, let's go ahead and graph these two piecewise functions and talk about their domain and range, okay? So, whoops. Okay. Starting out, we want to make a table, but first we want to show where our fence is going to be. So that's right here at 0. And then this x plus 2 is where x is less than 0, so that's going to be on this side. And then this 2x minus 1 is where x is greater than or equal to 0, so that's on this side. And again, we just want to make, a table with a couple of points, okay? So let's start here. Less than 0 means we could use -1, -2, -4, and you can pick any points. But we plug in -1 plus 2 is 1, -2 plus 2 is 0, -4 plus 2, -2. So let's go ahead and plot those. -1, 1, -2, 0, -4, -2, and we forgot we need 0 here. So 0 plus 2 would be 2. And should that be an open or closed? It should be an open at 2. Oops. And there's your line. Okay. Beautiful. Now let's go ahead and do the blue one. So we are going to plug in, its blue one is x is greater than or equal to 0. So, okay, we're going to plug in 0. And 2 times 0 is 0 minus 1 is a -1. Let's plug in 1. 2 times 1 is 2 minus 1 is 1. Let's plug in 2. 2 times 2 is 4 minus 1 is 3. So let's go ahead and plug these in. So 0, -1, and this one does have the equal sign. So we're going to make it a closed circle at -1. And then we're going to go 1, 1, 2, 3. Oops. And there's, oh, come on. There's that line. So that right there is your piecewise defined function. Okay. Now let's go ahead and write our domain and range in all 3 notations for that one. Okay. So domain, how far left, how far right is this going to go? Well, it's going to go on for forever in both directions. So we would write this, -infinity is less than x is less than infinity. Or we could say parentheses, -infinity to +infinity. Or we could say set notation, x such that x is an element of all real numbers. Beautiful. Now let's go ahead and do our domain, or sorry, our range. We just did domain. And our range, again, this is going to go up for forever. This is going to go down for forever. So our range is going to actually be the exact same thing, -infinity, but we put y here, to +infinity, or -infinity to +infinity, or y is an element of all real numbers. And there you go. Okay. So what I would like for you guys to do is try the last one, part B, on your own and see if you can come up with that domain and range as well. Okay. So pause the video here. And hopefully you paused, and this is the graph that you came up with. And I do just want to talk about the domain and range here, because if you'll notice, you should have drawn your fence at 1, which it's not drawn on here, but we know it should be here. Okay. But notice that neither one of these have an equal sign, the inequalities or the domain restrictions. So both of these are open circles. Okay. So in this one, your domain, it looks a little bit different. So we can go all the way to the left, all the way to the right. The arrows keep moving, but we cannot include this because 1 is not a solution. Okay. So our domain you could write as your inequality could actually it looks a little bit different, but you could just say x does not equal 1. Okay. And then when you write it in your interval notation, you would say, instead of from negative infinity to positive infinity, you would say from negative infinity to 1, and then from 1 to infinity. So this is kind of how you show that there's that break in the graph. Okay. And then your last one, the set notation, would look like x such that x is an element of all real numbers. But then you would say comma, and remember you just use your inequality form. Come on. So we would say x does not equal 1. Okay. So that right there is your domain. And then hopefully, if you guys don't mind, I'm going to do the range up here. I'm running out of space. So now our range, both of these point up, and there's nothing pointing down. So we need to look at where the lowest point is, which is right there. And that looks like it's at, you want to look at your y values. So that's at -1. So we would say y is greater than, and it's an open circle, so we can't put the equal, -1. And that's your inequality form. Then your interval form would have to be -1 to infinity with both parentheses. And then your set notation would be y such that y is an element of all real numbers. Sorry, I'm cramming this in here, comma, y is greater than -1. And that would be it. Okay. So I know this is a lot, but that is it for today, and we will do some more practice with this tomorrow during our Zoom. Okay, so we'll do practice with the domain and range and actually graphing these piecewise functions as well. Alrighty, you guys have a good one. Bye-bye.